Next, we are going to see this recursive functions. When a function calls itself again and again, such type of functions, we are calling it as recursive functions. Few points you have to remember if you're going to do recursive functions. There must be a terminating condition inside that particular function definition to come out of that particular function. And this particular terminating condition we will specify using if clause. And the values in the recursive function are executed in reverse order. Whenever the values are coming in each time of function call, it will be pushed onto the stack, one on the top of another one, until it reaches that termination condition. These values will be popped out later in the reverse order when it is going to come out from that particular function definition until that stack is empty. That means stack is going to pop out the last element first. So it follows a particular data structure called LIFO, last in first out. In this particular example, you can see the first value pushed on the stack, it is 1. On the top of that thing 2 is pushed, then 3, then 4. But when you are going to execute, 4 is going to come out first, followed by 3, 2, and then 1. Then afterwards stack will be empty. The next point which you have to remember is this one. Each time of your function call, local variable will get new memory space. And the local variable name will be remaining as same, but it will get different values. And these values will be available to the place where it is called when it's going to pop out from the stack. The three main disadvantages of recursive functions are these. The first one is it will consume more memory space. Then there is a chance of memory run out if the termination condition is not being checked by your coding, and it's less efficient in terms of speed and execution time. That means speed of execution will be a little bit slow and the execution time will be more. Now you're going to see how this recursion works in Python. Whenever you are going to implement recursion in Python, it must have two parts. One is terminating part, which will return the final value to the function calling statement, and the next one it is recursive part. It contains one of the more recursive calls on short part or a small code of your program. Now we are going to see the very first example of recursive function. I have written a recursive function named power with two formal parameters x and n. Whenever n's value is going to become 0, it's going to return 1. Otherwise, in the recursive part, the same function is being called again, x into power of x comma n minus 1. This function will be repeated until n's value is becoming 0. If it is becoming 0, it will stop calling itself. It will return a 1 value. In the main section of this program, I have accepted a number from the user, and in the second statement, I have accepted the power of the number which you have to calculate. In the next print statement, I have called this power function for the first time with these two values which are stored in the variables a and b. So power of a comma b is being called from here. It will directly go to the function definition, and the same function will be repeatedly calling unless you reach n is equal to 0. Here I tried to print the factorial of a number 2. So a's value is 2, b's value, the power I have written it as 3. So 2 raised to 3, the answer I got from the function, it is 8. Now I am going to explain how this works. first time we call this power function from the print statement. Power of 2 comma 3 is being called. At that time it will go to the function definition. X value will become 2 and n's value will become 3. In that one it will check whether n is equal to 0. That means 3 equal to 0. No. It will go to the else section. There returning is going to come like this. X into, that means 2 into power of x itself, that is 2 comma n minus 1. N is 3, 3 minus 1 it is 2. So the same power function is going to call within the function itself. That is second time calling. In that one, that power calling part is going to get replaced as 2 into power of 2 comma 2 minus 1, that is 1. So third time that power function is going to get called. That power section, calling section alone is going to get replaced as 2 into power of 2 comma n minus 1, that is 1 minus 1, it is 0. So fourth time that function is going to get called in your program. There, that power of 2 comma 0 is going to get an output 1 because now our n value is 0. It's going to return 1 to this particular part. So it will be coming like this, 2 into 2 into 2 into 1 equal to 8. But always remember, the first value which you got 2, it's going to get pushed onto your stack. The second 2 also is going to push onto your stack on the top of the previous one. Then third one is also getting pushed on the top of the second one. Third one is also going to have one more content on the top of it, that is 1. But when the stack is going to work out, that topmost element 1 is going to pop out first, followed by third one, second one and the last one. So the final result will be 1 into 2 into 2 into 2. That means you are going to get the answer 8. In this particular example, we are going to calculate the sum of first in the number limit as using recursive method. When this particular function is going to work particular function 1 named sum 2 plus 3 plus 4 is written with the answer you will get it as 10 because on one value you are going to decide your conditions, recursions, everything. We are going to see how the sum recur function is going to work out. In that one, it is checking whether n's value is less than or equal to 1. If it is so, and I got it's going to return see how it's going to work out. From the main function section of this particular program, sum recur of n minus 4. That particular part in the main section replaced we are calculating in its function definition as the limit of this particular calculation. It's being accepted from the user and stored in minus 1, that is 3. Print, then this part statement is being called. Within that going one, we are calling sum function of so n value, it is going to become 3. It's checking whether n is less than or equal to 1. It's not. So it will get into else part. There it will calculate again 3 plus sum of 2. So third time the function is going to get called in this program. But twice in the part of recursion. Then sum of 2 again is going to expand as 2 plus sum of 1. Sum of 1 is going to return 1 because n's value is 1 less than or equal to 1. It's getting satisfied, it will return 1. So 4 plus 3 plus 2 plus 1. Your answer will be 10. But remember, this 4 is pushed onto your stack. So that is going to be the first element of your stack. On the top of that one, 3. On its top, 2. Then at last 1 is inserted onto your stack. But when you are going to come back to this particular calling statement of your main section, the first value it is going to pop out is 1. 1 plus 2 plus 3 plus 4 is going to get evaluated in that order because of the stack functioning. So you will get the output 10.